Hey guys, so I'm having you guys do a pre-assessment today, and it is the mid-module. Now, we're doing this so that we can just see where you guys are at and what you guys know, so that we're not repeating any information that you guys already know, so we can just sort of blast through what we can blast through, and then the things that we need to learn we'll go over. I would like to give you guys a small heads up before you guys do the pre-assessment, because you guys should have a review even if you guys know some of this stuff. So this is on volume. Lila, I know that you've been waiting for this, so we are going through volume right now. And the way to find volume for a rectangular prism, and remember, a rectangular prism is a 3D figure. First off, that is quite important in this. I will draw you a quick one. So we've got our rectangular base, and then we've got 1, 2. Now I'm not the greatest 3D drawer, so bear with me. Okay, pretty good, not too bad. This is a rectangular prism. We've got our rectangular faces, and it's a 3D shape. Very simple way, but this would be an example of a rectangular prism. So when we are, I hope I said that right, a rectangular prism, I'm pretty positive I did. When we are finding the volume of 3D figures like that, it is volume equals length times width times height. So in this example, we've got here, I'm going to go over it in a pink so you guys can see the pink better. Okay, so on our example here, we've got our length, so the length of the rectangular prism, and then our width of the rectangular prism, and then we've got the added height, and those three components make it a 3D figure rather than just a rectangle. So what we do to find the volume, so all of the space that's in the middle of our shape, that is the volume. So another way of thinking about that, okay, so this is a little bit interesting, but here's a water bottle. Finding the volume of this would really be understanding what it can hold. So if I was to put and see how much water it could hold, that would be the volume of this water bottle. The capacity at which it can hold, which is the volume. So in this situation, it's a rectangular prism, and we're trying to see how much it can hold, what it can hold inside of it, the capacity at which it can hold, which would be our volume. So the way we find that is length times width times height. Super easy, super simple when it comes to rectangular prisms. That's why we normally start our volume with that. So another way to remember that, can you guys see this? Oh, I was afraid of that. It's too bright for you, but it says V, which would be volume, equals length times width times height. Another way to remember would be Victor lies when hungry. So if you guys want to write that one down, I can do so you guys can see it on a different. Victor lies when hungry. Victor lies when hungry because volume equals length times width times height. So Victor lies when hungry. That is one way to remember how we do how we find volume for rectangular prisms only. So we could even add to that. For rectangular prisms. Now he seems like he's a monster because he is, if we read this out, Victor lies when hungry for rectangular prisms. So he craves rectangular prisms. Makes it easy to remember that that would be the volume equation for rectangular prisms. Now, I am having you guys watch this before you do your pre-assessment because your pre-assessment's on volume, and not just any volume, but rectangular prisms. So if you guys know the Victor lies when hungry, you guys should be able to figure this out. It is only like maybe 4 questions, I'm pretty sure. It's not a long one. You guys have got this. Go get it. Good luck. And all I'm asking you guys to do is just give it a good effort. Give it your best effort. What you know, that's all I'm asking for. Just show me what you know. And I hope you guys have a good rest of your day. Bye.